At the end of the last video, I got cut off in the middle of my sentence, but I was trying to show that overall the molecule was polar because it had one chlorine pulling electrons away from the center, and this is only one direction of polarity, so this lack of symmetry made it a polar molecule. Okay, so now I want us to look at this diagram which lays out all the different types of shapes of molecules that you could probably encounter and how we can predict that that's the shape of the molecule. So on the left of this diagram, it shows us that if we take the Lewis structure, we can figure out how many electron domains there are, and then use that to choose which shape it would be based on how many of those electron regions are lone pairs. So let us use that color coding and number of electron regions to determine the predicted shape for these three compounds that we already drew Lewis structures of. So we already saw the Lewis structure of NH3. Looks like this with the lone pair on nitrogen. So now when I say we're going to count the number of electron domains, like it says right here in this bar, we need to count how many spaces around the center atom have electrons. So we've got this lone pair, we've got 1, 2, 3 bonds. That makes 4 electron domains. Okay, or electron density regions. So when we come up to, it's open. When we come up to the different numbers of electron domains, we'll see that tetrahedral is the general shape that has 4 electron domains. And we only have one lone pair, so if you look over to the right, one lone pair is the one that's labeled in pink, which is right here. So our NH3 is a trigonal pyramidal. It's hard to say. Trigonal pyramidal. Alright, then the next one is our structure of water, which has 2 lone pairs on that oxygen and then the 2 bonds. So that makes a total of 4 electron regions or electron domains. And if we look up on the chart for one that has 2 lone pairs on the center atom, we will see that it's the blue coded structure, which is bent. So water is a bent molecule. So if you try to draw it in 3 dimensions, those 2 hydrogens will both be pointing kind of downward and from the oxygen, and the lone pairs are up on the same side of the oxygen atom. Okay, finally, the structure that we saw for CH2O had a double bond to the oxygen and then a single bond to each hydrogen. So this is only 3 regions of electrons. So if we have 3 electron domains, we're going to have to look at a different row here. So on the 3rd electron domain row, our 2 options are bent or planar. And since there are no lone pairs around our carbon, we'll use the 0 lone pairs, which is yellow. So for 3 electron domains, that's going to be a planar molecule. So this one will be considered planar. And you can use this basically to predict the shapes of any Lewis structure. But you can also do the same thing with a 3D modeling kit, which we'll do just a little bit in class this coming week. And that's all we have for covalent molecules.